All right. So today we have my old friend, Emil Eifrem, founder and CEO of Neo4j. Their tagline is Uncover Hidden Relationships, Data, Meet Graph. Emil, welcome to the Data Exchange podcast.
Great to be here again.
Yes, yeah. Actually, the last time I had you, I was still at O'Reilly. So it was technically the O'Reilly Data Show, which was my podcast back in the day. And by the way, I have one of my favorite quotes ever from podcast guest in that episode, which was you described Neo4j, your company, as an American company with a Swedish soul.
That's right. That's right. I still use that one.
Yeah. All right. So let's start today with the state of graph and graph databases. So, I mean, where are we today? So back then, I think when I asked you the question about education, you said you still had to do a lot of educating. And now when I go to your website, I see that most of the Fortune 500 companies use graphs. Does that mean that you no longer have to educate people about graphs?
Sadly, no. There's definitely tons more adoption compared to whatever 8 years ago. I mean, across all sectors, small, big, whatever, verticals, and so on and so forth. But we still do a huge amount of evangelization, and a lot of it centers around the use cases. People have a few use cases kind of pegged as, oh, I can use graphs for this, right? But few people realize just how versatile they are, right? And so they might start with one, and it's like, well, wait, I hear my colleagues over there, they're looking into graphs for a different thing. Does that make sense? So a lot of it centers around that. So definitely less education than 8 years ago, but there's still a fair amount of that.
So what is the sequence of events these days? Do they come to you, they already have connected or graph data? Or they just have this vague notion that, okay, so I hear that for recommendations, we should be using graphs?
I think it's both, right? And people sometimes come in with a very nuanced and sophisticated point of view, and they've evaluated multiple graph technologies, and they've gone very far down the path, and that is certainly different from 8 years ago. That never happened 8 years ago, right? But then there's also, hey, I've heard for anti-money laundering, graphs could be useful. Can you please tell me if that's even true? And if so, like, how does that work? So we see both.
So 8 years ago, when we talked, the kind of the top line use cases were recommendations, fraud detection, master data management. So has any of the prototypical use cases, has something new emerged since then?
A ton of new stuff has emerged. They still remain very relevant use cases for graph databases, but there's a lot of new stuff, and we can, I'm sure, get into kind of the latest craze around LLMs and Gen AI and that kind of stuff. But even pre that, there's a lot of new kind of just classic business problems that we now solve in 2023, in 2022, in 2023 that we didn't 8 years ago. So anything that comes down to modeling the real world, right? And one of the things that I talk about is that kind of the premise behind our company is that everything is becoming increasingly connected in the world, and data describes the world. Here on this podcast, we talk a lot about data, but few people think about what data actually is. Data describes the world. It's a digital representation of the physical world, right? And so if the world is becoming more connected, data is becoming more connected, right? And so think of supply chain, which, a couple of, in 2015, you might have a supply chain, if you produce physical goods, that is 2-3 levels deep. Fast forward to today, anyone who's producing anything physical might have a supply chain that is spanning continents, taps into a fine-grained global mesh that is 20-25 levels deep, right? So that's kind of one example, but really, like anything in network topology, IT operations, we have customers doing railway networks, airfare planning. 99% of all the flight tickets in the world are calculated with Neo4j, logistics networks, that kind of stuff. So that's kind of anything modeling the physical world. That's kind of one cluster of use cases. Then anything that I think of as kind of whenever you have a journey of something, like a patient journey, right? Like, hey, I went to the hospital and then I got diagnosed with X and I got the following prescriptions, and then I come back for my next visit and my next visit and my next visit. So that's a patient journey. Very, very popular use case in pharma or healthcare. But that's of course technically the same as a customer journey, right? Same fundamental data structure, or really like a data elements journey throughout the enterprise for data lineage or kind of compliance reasons. That's also the same kind of core data structure. It's all about kind of that relationship between I did this and then this and then this, right? So that's another cluster of use cases, right? And then maybe the third one that I would call out, or I keep talking forever about use cases, but the third one that I would call out is all the kind of risk and compliance bucket, which is kind of first-party fraud, third-party fraud, anti-money laundering, liquidity management, figuring out risk contagion, right, across banks. That kind of stuff is a very popular use case as well. Again, I can keep talking forever, but that's some of the stuff.
So you've always had a lot of respect for traditional relational databases, and so almost everything you've mentioned so far, someone can shoehorn into a relational database or even a key value store, right? So at what point do people realize actually this graph databases are probably better?
Yeah, so there's maybe two things. So first of all, you're completely right that like all these new database models, at least the popular ones, are all isomorphic, right? Which means you can take information, you can transform it into the other data model without data loss, right? So if you ask yourself the question, can I model X in data model Y? It doesn't matter for any definition of X and Y, the answer will be yes, you can. So that's no longer the relevant or interesting question. The interesting one is that, is it a good fit for it, right? And that comes down to two key drivers for us, for graph databases. One is the really hard kind of objective, unambiguous driver of performance, right? So if you want to do multiple hops across that customer journey or patient journey or data lineage journey or that supply chain or whatever it might be in real time, right, millisecond type real time, then really you have to go to a graph database. So that's kind of the first one. That one tends to be, again, very objective and hard and number and quantifiable, right? On the other side is kind of the other driver is maybe a softer one, which is modeling ergonomics, right? With, yeah, I can shove it into a key value store, a document database, or a relational database, but it's really awkward. I'd have to do kind of a lot of join tables and foreign keys in the relational database, right? Or in a document database, I need to embed the unique identifiers of the other data or the other documents as properties in my JSON, which without no real support for it. And it's, again, doable. It's just hard for the developer or the data scientist or whoever is doing it, right? So that tends to be the second driver, just the developer data scientist experience with it.
So do you still mostly describe yourself as sitting in the operational as opposed to analytics? So OLTP as opposed to OLAP? So or has that kind of distinction disappeared for you?
It certainly hasn't disappeared. I think what Gartner calls HTAP, I think, like hybrid transactional analytical processing, right? Forrester for a while had a different term for translytics.
Never really took off or became.
I was going to say,
yeah,
that was exactly my point. So the distinction is still very real to me.
Yeah.
But yes, a massive difference compared to when we last spoke in 2015, or at least spoke on a podcast in 2015, is exactly this. Then we were, almost exclusively an operational data store, which, just to get the definitions right, for me, I think of that as kind of typically ACID transactional. You're the backend to an application written by a developer. You're the system of record for the world's applications. That's what I think of kind of that operational piece, right? And then on the analytical side, you're ironically, typically your system of record for history, right? So if you think about kind of even a Snowflake or a Databricks or something like that, people don't talk to them as system of record. I actually think they are. It's just that they're a system of record of the past. And then the question is, what do you do with that, right? And it's kind of the classic data warehouse point of view is that, hey, I'm going to run reports on that, try to understand the past, which is typically understanding my business, right? For people like me, right, these days, like I'm a consumer of reports like that about my own business, right? Or you use the past to predict the future. And that's typically more the universe of the data scientist. We now play in that part. And that's very new from back in 2015. So what ended up happening, and maybe I'll give you a little bit of it.
What's the relative percentage?
Oh, it's still by far bigger in the operational piece, but what we call the GDS, graph data science, is growing really, really fast. And I can throw a little bit of numbers in there. We went public back in 2021 with the fact that we've crossed $100 million in revenue, right? And I mean I can't talk too much about internal numbers, but our operational data store business is over $100 million in revenue. And the data science business is tens of millions of dollars and growing really, really fast, just to give you kind of a flavor of it, right?
So actually, Emil, explain that. So the graph, so I guess we can start referring to it as graph data science. It's growing fast. And so can you explain why?
Yeah. So we have an annual user conference at Neo4j. It used to be annual, then the pandemic came in and messed things up. Right?
By the way, when you explain why, don't limit yourself just to Neo, but just generally graph data science.
Totally.
Why is it blowing up?
Totally.
Yeah.
And so we have, and the first one we did in 2012. We call it Graph Connect, right? And in 2012, oh, were you there? I forgot about that.
Yeah. I went for a few times. I think you were at the Embarcadero, right?
Yeah, that's right. Yeah, that's exactly right. So in 2012, the first conference we ran, a professor from UCSD, so in San Diego, gave the keynote actually, and his name was Professor James Fowler, Professor Fowler, and he had just written a book called Connected. And what that book, and he was famous at the time.
Right.
You and I talked kind of off before the podcast started that we're kind of becoming old now, right? So this comes back to kind of ancient history, but he was the first external researcher to get access to the Facebook social graph. And he used that for social sciences studies. And he proved out something that is pretty mind-blowing, which is that, let's say that I know everything about Ben Lorica. I know your name, I know your gender, I know your age, your medical history, like all of that kind of stuff, right? That's one universe. And then there's a second universe where you're a completely blank note. I don't know anything about you, but I know your friends and I know your friends of friends. He proved out in that book that he could, with a much higher degree of statistical significance, predict much better things about your behavior in the second universe than in the first universe. So in other words, if he knows nothing about you, but he knows the graph around you, that ends up being a much more predictive signal. And that's a pretty shocking, if you think, I mean, stepping aside from technology, what does that mean in this world of right to be forgotten, for example? Even if I opt out, if these web systems know my graph, they can still predict things about me. But that's just a testament to just how predictive of a signal relationships in data end up being for machine learning or for any behavior. And so what happened to us was that just before the pandemic started, we ran our meetups, we did our conferences, all that kind of stuff, right? And one of the things that I always do is when I give a talk, I ask, get to know the audience. Hey, how many in here are developers? Raise your hand. How many in here are managers? Raise your hand. How many in here are data scientists? And we saw this surge of data scientists attending our meetups. And as you well know, data scientists don't generally want to put data into a database. Generally, what they want to do is they want to get data out of the database to put into their normal machine learning tool chain, right? But Neo4j was different. So they want to put data in there. And so we started talking to a bunch of data scientists and realized that people are starting to get a clue about the fact that relationships in data are really predictive. And so we started building out a product for that, which we called Graph Data Science. And that's the one that I just talked about that allow us just to play in that other bucket you can call OLAP or kind of analytical side of the house.
And so right now, if you were to describe to someone what are some of the key tools in graph data science, I would imagine you need a query language, Cipher.
Yep.
The user interface is what, a notebook?
Yeah, that's right.
And then you need some basic Python libraries.
Some basic Python libraries, and then it's your normal machine learning.
Data processing.
It's your normal machine learning toolkit, but then on top of that, you have exactly what you mentioned. You have, for example, Cipher, and there's other graph query languages out there, but of course we love Cipher, right? And the emerging GQL.
Basic tools to clean and wrangle the data and
that's exactly right.
Visualize,
that's spot on.
Visualize, right?
And so I'll get to the visualization, and then, but before we move kind of the processing stage, graph algorithms. So this ends up being like a really important one, because in most of these query languages, you can't declaratively express, a centrality algorithm or something like this. That's more of an imperative code type of a thing, right? And there's multiple other there's the Pregel model for compute and all that kind of stuff, right? But typically what people end up doing is that they invoke one of the graph algorithms, and they might calculate clusters. They might calculate, how important is this node in my network? That's called centrality, right? And, there's a rich set of those types of algorithms. And then you can express them. Either you can mark the graph back. The node Ben Lorica is very influential in the topics of data science and machine learning, for example, right? So you can mark them back. You can spit them out as embeddings, graph embeddings, which embeds information about the graph surrounding that node on that node. So that's kind of one thing. Or exactly to your point, you can then visualize them. So you can optically inspect and look at the graph result. And so that tends to be the kind of the standard tool chain.
And everything that you've described exists not only in your product, but do they also exist in open source?
They do, yeah. So our product is open source, but there's also a rich ecosystem of libraries out there with visualization. There's Python libraries for most everything out there, and so on and so forth.
And how popular in this space, Emil, is graph neural networks?
Yeah, it's a very interesting one. So the popularity of GNNs is very uneven, right? So what do I mean by that? Kind of in this pre-LLM world, right? That was one of the buzziest and most hyped areas of data science, really. And people, it's part of a broader umbrella of what's called geometric deep learning, right? Which has actually multiple branches, but one of the most popular ones, if not the most popular one, is graphs, right? So that's what graph neural networks are.
And there are several open source libraries: DGL, PyG.
PyG. That's exactly right. There's so a lot of buzz in academia about them. A lot of experimentation in open source, but a shocking lack of actual production deployment usage, right? There's some. Like Pinterest is kind of famous, so they hired a well-known researcher in here, Yuri Leskovich out of Stanford, right? Who went there and implemented GNNs at Pinterest. Google Maps has supposedly GNNs in production. Meituan is another example, right? And then there's
everything we've mentioned is really sophisticated tech companies. So accessibility is a problem then?
There's multiple things that is a problem, actually, right? So we mentioned a few now, and there's maybe a few more. Uber seems to have something in production for Uber Eats, but even though they've been publicly talking about using GNNs for fraud detection, they actually mentioned that they don't use it in production. So even inside of this really small kind of clique of, let's call it Silicon Valley, kind of top tier web companies, no matter what geography they might be based at, right? Like, even amongst them, I can really only get to a handful of companies that are using them in production.
Pre-Elon, at least Twitter?
No. So Twitter was never using them in production.
They hired or acquired some researcher, right?
Michael Braunstein,
Yeah.
but never used in production. We worked pre-Elon very closely with Twitter, and tons of experimentation done. But all kinds of problems with GNNs in production that it's not clear to me that they're insurmountable, by the way.
Yeah.
But kind of as of 2022, we went out and we talked to a bunch of supposed users of GNNs and uncovered some things that it's hard to find from just reading blogs, right? And one is just performance and scalability. Really kind of anything that does any kind of scale is very hard to shove into GNNs. GNNs typically have to operate all in memory. And to get any kind of performance, you need to use GPUs. And you actually don't have access to huge amounts of RAMs when you kind of or offload your workload to GPUs. So that ends up being kind of a challenge with kind of scale of graph.
SSDs don't help?
I'm sure they help a little bit, but kind of the cutoff between kind of RAM proximate to GPUs versus SSDs, that's a massive kind of cutoff. And training time tend to be very long, kind of days, if not weeks, even for fairly trivial size graphs, right? And then you have the classic kind of broad neural network challenge of opacity. And if you have bias in it and explainability and kind of all that stuff that you inherit out of kind of anything deep learning, right? And so I think some of those things, or many of those things, are the reason why there were very few today in production GNNs in production. So that's kind of an interesting thing that you wouldn't understand if you just look around on Twitter. I certainly didn't understand it. I got very interested in this kind of from following the blogosphere and the Twitter sphere. But once we went out and talked to real world users, the kind of the actual stage of production deployments was a little bit different.
Yeah. So our mutual friend Leo and I wrote a post on graph intelligence last year, and I kind of scoured the internet for all of these supposed GNN use cases. And let's set aside the fact that let's assume all of them are production, but they're still, even if you accept that, they're all just very advanced tech companies.
That's right. Yeah.
And so it just seemed like, and like you said, if you go on in the academic literature, it's insane the number of papers that are being published.
I was talking to an analyst at Gartner, and he told me that almost 50%, and they actually have that now he told me verbally, but it's now in print in several Gartner reports, that almost 50% of their inquiries in 2021 and 2022, when it comes to machine learning and data science, was about graphs. And that tells you a little bit just how hyped that area kind of was until LLMs entered into the scene. And then it's all about that, of course.
So the last time we talked, one of the points you made was this whole, in order for new databases to emerge, you need a kind of transition in platforms, right? So
that's
client
right.
server, you got Oracle. On-prem to web, you got MySQL. And then now cloud, at that point, you were making the case. Now the cloud, the transition may be to graphs, but I argue the transition, Emil, is to Lakehouse.
Interesting. Yeah, I wouldn't put a Lakehouse on the operational side. I would put that on the kind of analytic side. And I think there's an equivalent level of transitions going on over there. But it's an interesting kind of framing to look back on that. What I would argue to say is that since 2015, that has borne out to be true. And I don't mean specifically exclusively for graphs, but what we have seen in the 2010s is an emergence of a few new database companies at scale. And let's just take a step back and think about kind of databases, right? Like the relational database was invented in the 70s, right, by IBM, and really popularized by Oracle in the 80s. And this is exactly what it sounds like we talked about back then, which is on the back of the shift from mainframe to client server. That is what gave Larry Ellison kind of the wedge to go in there and establish the relational database, SQL and Oracle.
for our youngsters out there, let's not forget Informix and Sybase.
Informix, Sybase, and a few others, right?
Yeah.
And then there's basically nothing that achieved scale. Yes, we had, when you went from client server to web, and kind of that ushered in the era of MySQL, which ended up being deeply, massively deployed, but no real kind of revenue from that perspective.
And arguably, Postgres is still everywhere, right? So.
And Postgres, I think, has gotten a surge, since we last spoke in 2015. But if you look in the 2010s, what's happened now? We had this explosion of experimentation with NoSQL, right? Which led to over 350, database projects now tracked on DB engines,
and then MPP databases, and then the Hadoop kind of
on the analytical side.
Yeah.
That's exactly right. But if I focus on the operational side, right? Explosion of choice, Cambrian explosion, 350 plus database projects, over 100 of them raised funding, right? Formed companies, raised funding, right? Today, as we sit here in 2023, 5 have crossed 100 million ARR, right? 5. So Mongo, which is about at a billion. There's Redis and Neo4j, not Redis the product, Redis, it used to be called Redis Labs, like Redis the company, and Neo4j, which are on, both of us are on exactly that MongoDB path in terms of growth rate and that type of stuff. And then we have Couchbase and DataStax, who more plateaued a little bit and kind of more of a lower growth, great technology, can still become a great company again, but like it's more on a different path right now. But 5 companies that have achieved real scale, which I define as over 100 million.
This is on the operational side.
Revenue. And this is on the operational side. None of that would have been possible without the shift to the cloud, right? And so I think that's part. And then let's see now how that's going to shake out over the next couple of years. I actually think there's 4 distinct categories that are going to solidify on the operational data side of things. And then, of course, parallel on the analytical side, we of course have the rise of the, let's call it the cloud data warehouse, which is Teradata in the cloud.
Lakehouse.
No. The cloud data warehouse is one, right? Which is kind of SQL centric, data analyst centric, right? And it's really Teradata in the cloud, right? That's it, right? And much better and much more sophisticated and cloud native and all that kind of stuff. But that's really what it is. And then it's kind of the data lake and the data lake house, right? Which grew up in a different world out of the old Hadoop world, which some of our younger listeners will have to Google what Hadoop was, but whatever, grew up in that. And then which tended to be more code centric and more data scientist and data engineer centric.
But they're meeting.
And now they're converging.
Right.
So the cloud data warehouses are adding more and more support for data scientists and predictive features, right? And of course, the data lakes have famously added rich schema support, which allows them to do real kind of cost-based planners, and add SQL support, which turns it into the data lakehouse pattern. So they're converging into one. So I think there's going to be one broad category on analytical databases, and then 4 distinct categories of operational databases. I think that's the stable state. In 2030, that is what the landscape is gonna look like.
And and then now the latest thing that people are talking about, which I'm a bit, I think they're interesting, but I'm still a bit skeptical about their long-term future. Vector databases. So clearly, vector search and vectors are important, right? So and then the nearest neighbor primitive is going to be important, right? But I think what now is clear is that when you think of the term vector database, I think right now our focus is on the first word, vector.
Yeah.
But really, at the end of the day, you for enterprises to adopt this, you will need databasey features, and this.
Well, yes and no. Yes and no. It depends on how you shape the category. If enterprises think of it as a database, then yes. But if they think of it as a search library plus, then that's a different story. And I have a strong point of view here, by the way.
But then, even then, Emil, you will still need things like, scale, right? So you need to be able to scale. You need the things you talked about, latency, probably in the milliseconds. You will need some level of, data privacy protection, encryption, those kinds of things. And then one of the things that clearly not yet being done, Emil, is this notion of, I guess, incremental updates and streaming. In other words, I don't want to wait until tomorrow for it to have some updated information, right? I think right now a lot of these systems are still very much in the early days, in the sense that they even assume you already have the embeddings. So here's my embeddings, and then they give you some tool to load it to them, and then you can do your thing. But it's far from finished products, right?
Yes, I completely agree. Like, and the way that I think of them is they feel a lot like kind of search libraries, right? Like they feel like a Lucene or a Solr or an Elastic. They don't feel like a MySQL or a Postgres or something like that, right? And if you think about kind of just, and a lot of this I think you're spot on. It's about the name, vector database, and we focus a lot on kind of vector, and people, for good and for bad reasons, think of vectors as leading them to LLMs, or being a central integration point with LLMs, and we can talk more about that later. But that's the vector part. And the database part, if you think about kind of the etymology here, right? It started out because initially there were only vector search libraries, right? This is the faces of the world, and so on and so forth, right? And then, people ran into all kinds of kind of scalability, performance, operationalizability kind of concerns with it as they tried to put that in production, right? And it was exactly what we all saw 10, 15 years ago with Lucene, right? Which is, Lucene is a fantastic embedded Java library, but if you want to use it, everyone kind of have to reinvent the same wheel, and that was ultimately what gave us Solr and Elastic and these type of different things, right? And so that's what these projects that are now called vector databases, I think, try to solve kind of in the early days. And then they just ended up calling it database because it certainly felt more databasey than the libraries. And from that perspective, on a relative basis, I guess I would agree with that. Of course, from an outside-in perspective, I tend to think of a database the way that I said at the top of the call, right? Which is kind of OLTP, transactional, ultimately the backend to an application written by a developer. And that is not how these vector databases feel right now. They feel, again, more like Elastic++. Now, there is an argument, and I think here's what you have to believe in order to believe that vector databases are going to be a large, durable category inside of operational data stores, right? You would have to believe that basically, one, there's an emerging kind of very big class of what I think of as ANN first applications, right? So, like applications for whom like nearest neighbor semantic search is like a key function, right? Two, vector databases are several orders of magnitude better for them than other databases, even if other databases add support for vectors, right, as a feature. And then three, they're going to remain orders of magnitude better than the other databases for a long enough time that they can build into the full feature set of an robust, enterprise grade operational data store before those other databases add vector search that can catch up with them. So I add those things together, and when I say that the operational data store landscape is going to solidify across 4 segments, right? Vector databases is not one of them.
So clearly, because of where we're at in terms of deep learning and machine learning, embeddings are important, right? So they're like the lingua franca of AI. So you will need to have a strategy around embeddings. And so one of the first questions you'll ask is searchy kind of questions, nearest neighbors. But that doesn't have to be the only question you ask. It just happens to be the canonical question that you ask. And so to your point, the question is, can other systems add this capability, or is it too hard for other systems to add this capability? Like, for example, you can imagine a lakehouse being able to store embeddings and doing some of these capabilities, or Elastic improving on their nearest neighbors, and things like that. So yeah, it's
And I think it's
unclear.
much more likely that Elastic does it, because it feels like it has that shape. And when I say that I don't believe vector databases is a durable kind of operational database segment, I still think they have a real place, right? It's just not as a database. And I think that's the distinction for me. And I think they feel much more, again, like an Elastic than MySQL.
Yeah, and then they will have to be able to do some of the basic things we discussed, right? So metadata filtering, streaming, and real-time updates, and those aren't happening. But then, as you point out, it's reminiscent of those previous eras in the sense that a bunch of open source projects equals a bunch of well-funded companies. But then what's the revenue is still unclear at this point, right?
Still TBD. And I think, look, again, I don't believe they're going to end up as an operational data store, right? But on the flip side, again, I think they have a valuable place in the ecosystem. And then the question, how big is the size of that market? I think that's going to come down to exactly what you're talking about, which is when Elastic improves their support, right? When Postgres has PG vector.
Right.
We're adding support for vector data, and we actually already have support for vectors in our GDS layer. So the graph data science, the in-memory compression image that is graph data science, right? So we already have support for vectors there, and we're adding it in the core database as well, right? So when all these other data platforms add it as a feature, right? How much oxygen is that going to suck out of the space, right? And look, there's a real argument to be made that, hey, at massive scale, or when you do like kind of this hybrid, I have BM25 and I have vector and I'm doing this and that, right? For that, you need a standalone service, right? And so that could pan out to be true. And then the question is, how big is that market? And I think, time will tell.
But that's a very, very specific use case that sounds like search and enterprise search.
That's exactly right.
But then going back to my earlier point, where the embeddings might become important on their own for ML or whatever other type of use case. Yeah, so it's unclear whether or not the current systems that came out of vector search are going to be the right systems, right? And then Emil, to your point, as more of you existing solution providers, whatever you are, graph databases, search, lake houses, add some of these capabilities. I mean, the natural inclination of IT teams is to have fewer systems, right? So, well,
I think that's right. And like fewer vendors, less data to be shuffling around. And then the question is, can the standalone system be 10x better? Right. And I know this deeply well because I've lived through this. Like at the first wave of graph databases was people dismissing it as niche, right? It's just good for the social networks. And then the second wave, as kind of some of the enterprise use cases became established, then the other database vendors said, like, that actually is important. But hey, let's add graph as a feature, right? All of them failed. Every single one. There's not a single one of them around anymore. Right, and so that all failed, and it ended up being that the native graph implementation, that was the real one that could do it kind of at scale with performance and with the ergonomics that developers want and data scientists want, right? And so could we as incumbent vendors be underestimating kind of the vector search problem? It's quite possible. At least how we look at it here at Neo4j, and the kind of the journey that I went on was, I saw kind of vector databases, partially thanks to your podcast, by the way, and your writing. And then it's like, all right, this looks really interesting, but not really something that's related to what we do. But then a lot of smart people start talking about it kind of in the same broad bucket as graph databases. I was like, why do people do that? And then as I delved kind of deeper in it, this happened also with the LLM craze, right? Then it's like, wait, actually, one way to think of vector search right, is, you know what? Hey, Ben Lorica, ultimately what we do, before I go into the example at Neo4j with graphs, right? What we do is we capture explicit relationships.
Right.
There's a Ben Lorica works at Gradient Flow, right?
Right.
That's an explicit relationship, right? Ben Lorica is friends with Emil Eifrem. That's an explicit relationship, right? But then you can imagine, one way of looking at vectors is that, hey, there's a lot of web pages that put O'Reilly as a concept and Ben Lorica as a concept close to each other. You
Right.
can think of that as an implicit relationship between Ben and O'Reilly, right? And that, once I saw it from that perspective, it's like, wait, that's super interesting and relevant to what we do. Ultimately, what we want to do at Neo4j is, our mission statement is help the world to make sense of data through relationships. And now I can think of vectors as just implicit relationships. And then what we currently do with the property graph model is being able to express those explicit relationships. And then I look at all that, and that's a very cohesive product strategy. So that's why we're adding it.
So Emil, so going back to this notion of embeddings being the lingua franca of AI and being important, so do you foresee a possibility that, embeddings become part of an operational system? Because basically, I mean, if they're important, then you compute them up front and then store them, and somehow they're available for all sorts of downstream applications.
100% for serving. I think that's what we're seeing right now with what we're doing, adding vector support to Neo4j, for example. So 100% for serving. I think for computing them, that's kind of interesting because, as you well know, it's a little bit of a weird thing going on right now where everyone is storing these vectors, but they're not actually offering up the service of computing them, right?
Yeah.
And so you have to do that externally somewhere else.
That's what I was saying. Is that they assume they already exist, and then you have to shove it into their system, right? So
yeah, and so I think that, yes, they're part of operational systems for serving. Now, the entire path for computing them, I think some of that is going to be integrated into these systems, but then you get into some of these tricky things with keeping indexes up to date with the data that you had in real time, right? And in the database world, we've lived through this for a long time.
This is my point. The word database is more important than the word vector down the road, right? So,
yeah, no, that's exactly right, because that turns out to be a very non-trivial problem, right? Because you have to have with, especially if you're ACID compliant, right? Like you have to have with absolutely sub-millisecond, you commit something and it better be available to everyone at the same time as an atomic unit. That includes your indexes. That's not just your data store files. That includes your indexes, right? And we've kind of painfully learned to do that with kind of B+3 indexes and with, BM25 and inverted indexes and full text. I think we now need to learn how to do that with vector search and kind of ANN and all that kind of stuff as well, if we're able to do that truly in real time for us operational systems.
So so right now in the LLM world, right? So I think one of the things that people are realizing now is that while they're great, the general purpose ones are great, but they're general purpose, you need something more tuned to your domain, right? Fine-tuned to your domain or whatever. And then the other popular notion of hybrid, you mentioned hybrid search, meaning BM25 plus some kind of vector search. But the other notion of hybrid is this retrieval augmented system where you have some kind of vector search or knowledge base. You go to an LLM, ask it a question, then you check your knowledge base or vector database first, and then the LLM might summarize the results. So long-winded way of asking you, what are we to make of knowledge graphs and knowledge bases? I mean, are they just part of the graph database world? Are they special case, or what are they moving forward?
I think it's an amazingly good fit with LLMs. So what is a knowledge graph ultimately? A knowledge graph is taking whatever data you have inside of your enterprise, which might be stored in a data lakehouse or in a data warehouse or something like that, ultimately chopped up in tables, right? You take that and you express how all the different concepts in your enterprise, how they relate, right? Who are your different customers? What systems are they connected to? What other customers are they connected to? What products are they connected to? Those products are stuck in a put in a hierarchy. Those products connect to the supply chain. Express all that in a knowledge graph. It's the knowledge about your entire enterprise. That's a fantastic complement to a ultimately statistical, probabilistic, language-centric model, where one can do all kinds of magic that we've all kind of seen and lived and tried out for the last 6 months, right? Since ChatGPT was launched.
And also hallucinate.
And that's exactly the point. Like, it's great at the probabilistic stuff. If you can match that up with actual facts, actual knowledge, that's a really powerful combination. And some of this is, people end up calling it grounding, right? So you want to ground it in the facts of your knowledge graph. And I think it's a really, really powerful concept that I think is going to be critical for enterprise use of large language models.
So Emil, the reason that people, the first thing they augment an LLM with is a vector search library or vector database is because there's some level of automation there. In other words, here's a bunch of PDFs. There's known ways of taking those PDFs and turning them into embeddings, but there's no such thing in taking PDFs and turning them into knowledge graph, into a knowledge graph or knowledge base, right?
No, there is.
There is.
There's plenty of existing kind of pre-LLM practices for doing that, for extracting unstructured data, which is ultimately PDFs as one version of many of unstructured data, and turning that into your knowledge graph, which people have been doing for a long time. Obviously, Google was kind of the OG knowledge graph on some levels, but in the enterprise as well. But it's really been given superpowers with the LLMs. So one very popular use case for LLMs and knowledge graphs is ultimately entity extraction, right? Where you throw that, let's call it a PDF, or that document, to an LLM, and you ask it to extract the relevant concept, and then you can today you can ask it, express that in Cypher, and then you can add that into your knowledge graph.
That's gotta be slow, man. Because basically, now if you're going to go to an API, external API, then give it this prompt, and then your input data is long, you're talking 30, 40 seconds per question there.
You're spot on. Like, and this is why this space is so early, right? Obviously, if you want kind of lower latency stuff, you would deploy a much smaller model, right, on your own, kind of self-managed, either kind of on-prem or in the cloud, rather than going to kind of the open AI APIs or something like that.
Super fine-tuned to extract the entities that you're interested in.
Yes, maybe fine-tuned, but actually even off-the-shelf models today do a really, really good job of it. Actually, entity extraction ends up being not, like, if you're trained on English, or on language, ends up being not a particularly specialized skill set.
But what if I want to extract entities from a super niche domain, like, oncology or radiology, or, you know what I mean? So then you will need something.
Maybe.
Yeah.
Maybe. I think this is where we just don't know how this is going to unfold yet. Like, how general purpose are the kind of the generic pre-trained LLMs, right? Versus the more specialized one. And then you can add the fine-tuning on top of the general purpose foundation models. Like, it's very hard to tell how far we're going to go. I've been impressed so far, not even from playing around myself, but from what I see our customers do. I've been impressed at what the more generic foundation models can do with fairly specialized, in fairly specialized domains.
So right now, as I interpret what you've been saying, is the workflow right now is augment, at least from what you're seeing from your customers, is augment an LLM with a knowledge graph, and a knowledge graph can be stood up with some existing tools, right? So here's a bunch of documents. some existing tools will take those documents, create a knowledge graph, and now I can augment an LLM with this knowledge graph. Is this a fair?
That's exactly right. And then, yeah, exactly. And then you use kind of RAG, retrieval augmented generation, which you mentioned before, which today in the like kind of real world as of June 2023 ends up being much, much more practical than fine tuning. And again, such a fast moving space. Who knows where we are in 2024? But at least today, getting that data out of the knowledge graph and passing it along in the prompt to the LLM for summarization, for example, right? That ends up being the most practical way of doing it today. And so you really have kind of two branches here, Ben. One is, how can I use LLMs to enhance my existing or new graph project? And that's using kind of LLMs to create the knowledge graph from unstructured data, as we talked about. It's also chatting with your knowledge graph. Hey, I don't want to learn Cypher, or I just want to ask it in English, and then that's kind of another example of it. Or we have, API calls that you can use in real time to enrich your knowledge graph, right, from an LLM in real time. So that's all kind of part of the broad bucket of use LLMs to enhance a knowledge graph project. That's kind of that one. And then the second one is use a knowledge graph to enhance your LLM. It's the other way around.
Right.
For some application that you're building that you want to use an LLM, this is where the grounding comes in, right? This is where it's like, hey, my go-to example is one of my board members is Patrick Pichette, and he was the CFO of Google for like a decade and the chairman of Twitter. And if you kind of do a vector search on Patrick, or you ask an LLM, it's not unlikely to come up with, hey, Patrick is the CFO of Google, right? Whereas he's actually a board member of Neo4j. So if you have your knowledge graph that says Patrick is a board member of Neo4j, no matter, and then you ask your LLM to write a bio about Patrick Pichette, and then if it comes back and says he's the CFO of Google, you can look at that and compare that to what's in your knowledge graph, and you can either kind of reject it, you can ask it to rewrite it, or you can just replace it in line, right? Those are or just flag it. Like there are various things you can do, but that's all part of that broader grounding the LLM in the facts of your enterprise organization's knowledge.
So, so a couple of things. So first, when we started this conversation, we alluded to two buckets, right? So kind of the transactional and then analytic, and then basically in many ways. So you've got your transactional offering, your graph data science offering. This potentially could be used by anyone. Doesn't have to be a data scientist, right? So it could
That's
be
exactly
like
right.
basically analyst, anyone who can write prompts can use this. So how far is this category from being real? In other words, I take it that most of the things you describe are still kind of toy, people are playing around with it, kind of stage, right? So and then as we pointed out, there's still a lot of things that need to be worked out in terms of performance, like taking, I don't know, like 100,000 PDFs and turning it into a knowledge graph that could, right now, the way we describe it, that could take forever, right? So how far away are we from realizing this kind of third bucket of non-tech people, non-data scientists, just basically everyone?
Yeah. So for bucket 1 and 2, we have LLMs in production already today, massive. I just talked to a Fortune 200 oil and gas company who's using it to chat with their knowledge graph through the LLM. So that actually does exist. In terms of broad-based deployment of the third one, it's very unclear to me. I think the building blocks are there. It's very early. People are figuring things out. Obviously, if you look away from the LangChain ecosystem for 4 minutes, they've built 38 new things and
oh my God,
all that kind of stuff.
Yeah.
But having said that, what I think the high order bit is for that third bucket, which is, let's call it democratizing access, right, to this, if you're not a data scientist or a developer. That feels to me like a UX kind of problem, right? The high order bit. Like, do people we'll get the building blocks in place?
Well, I mean, the
but
UX.
do people want to use a chatbot interface to their data, or do they want a visual interface to the data, for example? Like, it's not clear to me how that's going to unfold.
I think it's a combination of both, right? So the interface will be chat, but you could probably also imagine people feeding it, here's an image, I have a related question to this image, right? So multimodal. And then the return will be multimodal in the sense, okay, I'm answering your question, here's a chart down the road, doesn't exist yet. And then maybe some annotation explanation for why this answer was produced, right? So to reassure people. But all of that, the pieces are there, but a lot of it may not have the performance level. And also, Emil, the related question I have for you is this notion of custom foundation models, right? Because basically there's, as listeners of this podcast know, there's many reasons why people may not be comfortable just using these public APIs, public LLMs and whatever, right? So let's take it for granted that people are going to build this custom foundation models. And there seems to be some open source artifacts that could be used as starting points that are starting to emerge. Are these actual conversations you are having with CXOs? Are they actually interested in building their own custom foundation, custom LLMs? Are they interested in LLMs at all?
Oh my God, we hear it all the time, all the time,
Yeah.
right? Now, there's a lot of confusion out there. I hear a lot of people asking for training their own LLMs, right? And then kind of what you have to do then is to kind of try to understand the question behind the question, is because it turns out that that's a proxy for them saying, I want it to run on my own data, right? Or I don't want it to hallucinate.
Right.
And then, as you well know, the answer today usually isn't train your own model from scratch. It usually isn't even fine-tune your own model. It usually is today retrieval augmented generation, pass along, core set of information in the shape of documents typically through the prompt and ask the LLM to summarize that or operate on that somehow, right? So people ask for it, but that's the kind of the outcome they're looking for is actually different than technically what they're asking for.
And that's the easiest path right now is the retrieval augmented. Ultimately, I think it'll be a combination of fine-tuning, retrieval augmented, and honestly having a decent base model, because basically, while there are a lot of open source models out there, it still makes a difference if your open source model is one of the better ones, honestly.
That's right.
Because basically it still needs to understand the prompt and the question and direct the knowledge graph or vector search engine accordingly.
I think that's spot on. And the two things that I end up focusing on is one, what is the clear pattern, like a simple, easy to use pattern through which you can give the enterprise's internal data, give access to an LLM, and not necessarily a public, right? But some LLM, however it's deployed, right? Operate by that enterprise or by other people, right? But how can I give that subject to the enterprise's privacy controls, access rights, like all of that kind of stuff? That's kind of one big piece. And then the other big piece is this grounding in fact. There are very few enterprise use cases that I can think of where the hallucination is okay, right? And that's why kind of grounding the LLM in the facts out of the knowledge graph, I think, is such a powerful concept. And those tend to be the ones that emerge out of my conversations with customers, at least right now.
So you think that this custom foundation models, custom LLMs, this is basically going to happen all over the place, in the sense that they don't necessarily, very few companies will want to rely completely on a public API. That
I think absolutely. Like if we talk about the enterprise, obviously, at Neo4j, like we talked to a bunch of startups and individual developers, and I think that's a very different universe. Inside of the enterprise, I think that's going to be, close to 100%.
Yeah. So training from scratch, we don't recommend it at home because I think basically the real high-end models, you're talking 5,000 to 10,000 GPUs. I mean, the low-end models, maybe you can get by with 1,000 GPUs. So that's still a lot of freaking GPUs.
That's a lot of H100s.
Yeah, which brings me to another question I have, Emil. So graphs for a while, the thinking was, well, I mean, GPUs, right? So we can get by with using GPUs. There were GPU databases. Nothing happened there. But GPUs for graphs, our mutual friend Leo, he's still at it. So it seems like there's still value there. So is that something that you think will become more of a thing? GPU related tools for graph related data?
Yeah, I think over time we'll probably see some of that. It's not a major trend we're seeing right now, and Leo is much closer to it than I am. The closest we've gotten to it, kind of in the last, let's call it 12 to 18 months, is through what we talked about before, which is GNNs, right? And kind of that GNN affinity towards GPUs. So we've certainly seen that, but other than that, it's not a big thing. I also think just there's such a sucking kind of black hole. All the oxygen and vacuum for GPUs is getting into kind of these generative models right now. And so I think like it's very hard to get kind of GPUs allocated to anything else at this point. And there's a lot of existing kind of world-class tooling. I mean, I'm speaking self-serving here, right? But that works for graphs without GPUs today.
Okay, so in closing, this is becoming like my longest podcast ever because I can talk to you forever. You moved back to Sweden. So I know you spend a lot of time here, and I can tell you, man, the hype here is really quite out of control in terms of AI and LLMs. And I would argue this is actually a great place to be back in the Bay Area because of that reason. So what's your advice to all of these entrepreneurs now who are trying to build these companies with apparently no moat at the moment? So Emil, remind our listeners, so when you guys built Neo4j, did you get the revenue right away?
Yeah, so we open sourced right from day one. And so we started building a community from day one, but we were a little bit contrarian, and we started monetizing pretty early as well, because we just felt that, hey, we want to get kind of both signals of feedback, both from the open source community as well from paying customers. And we also knew that if you looked at a database company, any database company at scale, 80% of their revenues from the global 2000. And so we knew that, hey, selling into the enterprise is not like an afterthought. We need to train that muscle right away. And it's easy as a kind of a deep techie open source company to get all caught up with the kind of the hipster next Soma startup, whatever, that type of thing, right away, which I think back in the days was like solo mo or something, like social local mobile or whatever, like all those kind of things, right? And so we didn't want to be just that. We wanted to do both at the same time.
I think this era's closest analogy to you might be these vector database companies, in the sense that back when you started, clearly graphs are important. What do we do about graphs? So same thing here. Embeddings are important.
Very similar.
What do we do about embeddings? But what's unclear to me, in your case, it seemed like you were not necessarily one use case kind of thing. Here, I'm not saying it's one use case, but it seems like the nearest neighbor search seems to be the thing. And so does that kind of bother you about the prospects of this category?
Yeah, it does, right? Like I think that's the sense that I have as well. Now, that one use case might still be elastic scale, right? Which is built a
But there's
billion
already
dollar
elastic.
plus. Exactly, right? And so can it disrupt them? And then the question is, all the new use cases around LLMs, are they big enough to really warrant a massive category, right? Now, what I will say to that is that everyone always thought that graphs were niche. That was kind of the one thing that people always told me. Yeah, it's really cool, but very niche. And we saw the real world use cases with customers and believe this is where the world is going. And so maybe I'm doing the same thing to these vector databases. Say like, well, I only see like a few of the use cases and they're valuable, but they're not massively broad. So, I have to stay kind of intellectually honest and humble about that. But yes, I mean, I think that is a very, very close analogy.
But it's not like Emil, they have so in the graph database situation, right? So it's clear that, as we mentioned, you could stick any graph connected data into, key value store, relational database, whatever, right? So, but it was clear even then, even if you do that, it's clear that, okay, so if I actually have a graph database, it's probably better, it's faster and all of that.
Yes.
In the vector embeddings, vector search case, I'm not sure yet if there's some kind of secret sauce that, what if I stick this into a lake house or into Elastic and they kind of add some basic capabilities? Can't they get close to what these guys are doing? It's unclear to me that they can't, right? So,
I think the secret sauce, the way that I think about it here, has to be either some combination of that hybrid search, right? The BM25 plus
but that's
this,
search.
plus that, plus
That's
this,
search.
right? On search,
Yeah.
right? And or there's something about scaling out the indexes that is not clear, that it is very different from scaling out other type of data. Like, and we of course saw this with graph data, where like for the longest time, the moniker was always that, Neo4j doesn't scale or graph databases don't scale, like type of a thing. It turned out that the actual story behind that was that graph data is hard to scale. And everyone who tried to just shove graph data in a different scalable system turned out that didn't solve the problem, right? And maybe that's also true kind of for vector data in a way that I don't understand right now. But I think it's one of those two things that have to be the secret sauce in order for it to be broader than kind of the next elastic.
So here's my pushback to that point, which is, I think though that the people working on vector search and vector databases, they're not necessarily the people who are the scaling people, the distributed systems people, right?
Yes.
So, and in fact, the distributed systems people might be able to add the nearest neighbors much more easier than the nearest neighbors people can add distributed systems.
And that's the big like decision for founders and investors and maybe even customers to think through before they kind of invest either their time or their money into these new solutions. It's exactly what you just said right there, I think.
Yeah. And so final parting advice. How does one create moat in this no moat world at the moment?
Proprietary data. I think it comes down to that. Like you have got to have access to proprietary data,
So
and then
does that mean focus my efforts in creating a solution in a specific vertical, right? Right. So whatever it is, right? So do something deep and specific in cybersecurity or something. Is that what you mean?
I think it is different for different verticals and different go-to-market motions. You have the different kind of spaces where you have data network effects, for example, right? So that could be kind of another way, but ultimately it's about creating a bunch of unique data, which you then can leverage in these LLMs, again, either by kind of fine-tuning them, training them from scratch. Don't try this at home, but it's technically possible, right? Or through something like RAG, right? Pass it along to the LLM. But I think that's what it ultimately comes down to. You got to have that data, proprietary data set that's going to be the sustainable competitive advantage in this kind of post LLM world.
Yeah, because the lock-in seems to be in the data world is either network effects or data.
That's right. I think that's spot on.
Yeah. And with that, thank you, Emil, the my favorite American company with a Swedish soul.